Good morning, everybody. Yeah, so the topic will be the Internet of Laboratory Things. Now, for the ones of you who are scared now about the perfect storm, so I'm not talking about the total disaster in the lab, it's actually the opposite. It's the meaning of the perfect storm, like a rare combination of circumstances that are leading to an event of an unusual magnitude. So something really great, a great experience in the lab. So that's actually the idea about it. So I will be talking a little bit about the Internet of Laboratory Things, then what are these things actually, and what other ingredients do we need to consider to get to this perfect storm. And I will show a couple of very quick examples how this can look like from a BioVia perspective. So the Internet of Things. What is the Internet of Things? Just back to the basics. And it's physical objects. So it starts with physical objects that are connected in a network and to collect data. And I actually read this morning the number of things that are present today in the Internet of Things. Anyone has an idea? Just order of magnitude. How many things are in the Internet? 1 billion? More. Other numbers? 8? Wow, almost spot on, very good. 8.4 billion things, objects, are in the Internet of Things today. I think this is quite impressive, and I think this actually also shows there must be in value. And maybe not yet with some things like the fridge that is telling us, you need to buy chocolate, or you need to buy champagne, or whatever important things you might have in your fridge. But it's also smaller things, like the toothbrush that is reminding you that the time you need to brush and already sends the data to your dentist. So there are many, many things, or the Fitbits that many of you might be wearing today. So plenty of examples that we have today in the Internet of Things. But what about the lab? And I think that the lab has a big interest in connecting physical objects and to use the data. And so it might sound funny here that it's about fire extinguisher and offering a contemporary house, and now you know that it's burning. But it actually shows the idea behind, because this is actually preemptive action. So it shows the data, and that this is actually something that we can use in the lab. And I will show a couple of examples later. So it's interesting because of data integrity. We have the things, whatever these things are, directly connected. So that means that once we have invalidated the interface, we can be sure that we have data integrity. And from a 21 CFR Part 11 compliance, that's an important point. But it's also about data quality, and Peter has mentioned Alcoa before. So from this perspective, it can help. And once we have connected instruments, it's not only about reducing errors, but also increasing efficiency with minimizing or even removing non-value-add activities in the lab. And we get more data because we have all these things connected, so we make sure that we are not leaving out any data. And we get more data because we can get metadata. We can contextualize the data, so we have more. And this helps us to get an overview of what do I have today, but also insight. And this insight can be this maybe trends that I want to see, or deviations, or changes, or, like we see here, maybe leading to some preemptive action. So there is value. There's an interest in looking into this Internet of Laboratory Things. And it's really cool. Now you might say, yeah, whatever, cool. We are scientists. We don't need cool. But I think you need to have cool. Because if you look at the lab, who is working today in the lab? Many of them might still like to work with paper and might have their Post-its around. But if you look into the new workforce, Generation Y, Generation Z, if you want to have really skilled people, you cannot come with something like this. And they expect, actually, to have this network. to have a certain degree of automation, of integration. This is what they are experiencing today. So, and this actually brings me to the first challenge that we actually have in the lab, the equipment. Because I want to know what equipment do I have in the different labs, maybe globally. And what's the status? Can I work with it now? Is it in order? Is it calibrated? Is it under maintenance? And I would like to collect the data, obviously. But how can I do it in an efficient way? In the traditional way, when everything is disconnected, and it might not even have to look like this, but usually what we see in the labs are disconnected equipment and instruments, and siloed information. So how can I collect this efficiently? And if you have a balance and you say, yeah, well, it's just one value, I write it on a Post-it and I type it in later. This might still be okay. Could be optimized, but in a certain workflow, might still be okay. But you have larger equipment with an XY data set or even more complex data sets. So then it really is important to look into this efficiency part. And again, how can I ensure integrity and quality of the data? And for reusing data, it becomes even more important. So I want to reuse it maybe for other experiments or to make some decisions. For example, for the equipment, when we want to see, does something have to be replaced, or do I need to relocate instruments? So this is actually very important, and I have challenges if I don't have this kind of connection. And there are more challenges in the lab environment that I think are leading us to rethink the lab, to get to a new lab experience. And it's a lack of integration, but not only of instruments, but also of systems. So very often we have different systems in place, electronic systems. And when they are not connected, I have to do the steps of data transfer manually. That's error-prone. And the more systems I have, the more difficult they are to configure and to maintain. And coming to the topic of standardization. So we already heard a little bit before about that. Standardization is important because if not, it's very difficult to collaborate, to exchange data, or to use the data on a later stage. And from a compliance perspective, it's also creating much more effort. And if we look into standardization, not only for methods and processes and materials, but the data we are creating, then it's really difficult to transfer the data and to create knowledge with it and share and reuse it. And data silos mean, and I actually heard this quite a bit during this conference yesterday in conversations and asking, where are your challenges today? I heard it very often, it's the data silos, is how can I tap into the different data sources and gain some intelligence out of it? And this is very difficult. So how can I integrate it and how can I use it, visualize data, analyze the data? And lastly, and I think this is something that might not be so obvious, but it's definitely also something that makes our life in the lab a little bit more difficult, is that we have overlap of capabilities. The more systems I have in the lab, the more overlap I have. And again, this is difficult to maintain, and it also creates a poor user experience. So sometimes people don't even know which system to use for which capability. So we have a couple of challenges, and we see that something can be improved in the lab. So let's take a step back and have a look at what are these things actually. What are these things in the lab? Obviously, it's equipment. That's very straightforward, and this is what comes to everybody's mind immediately. So we have the smaller equipment, like balancers, pH meters, titrators, a little bit more complex instruments that are creating XY data sets, like spectrometers, or a little bit more complex, like chromatographic data systems from the chromatographic instruments. And it really makes sense to connect them to get to more insight into what I have and what I can do in the future. What else do I have in the lab? Well, there are more things. For example, the things to capture data. I have mobile devices, and where a scientist or a lab analyst can just enter the observations of an experiment. Then for automated identification and collection of data, we can use barcode scanners. We can use, for example, radio frequency identification with devices that have tags, or near-field communication with a communication protocol. So these are opportunities that we have to collect the data. It also is part of the things that we have. And then we have some other things, which are the people. Okay, I don't want to say that the people are things, but we have devices, things that are really directly giving information about the people or to the people. What does this mean? Well, for example, biometric bracelets. Today, it's like this when somebody comes into a lab, types in username, password. Why? Identification could happen with a biometric bracelet. Much easier, much quicker, reliable. Or wearable displays, just to get a quick information about a sample or get an alert when something needs to be done in the lab. Or heads-up display for augmented reality. So we already heard that before a little bit, like wearing safety glasses that have a display with a procedure or something that needs to be done, or looking at an equipment and you get information about it. Or using technologies that are coming from other areas, like motion sensors, that can actually trigger the recording of how an experiment is performed. So these are already getting into a more futuristic scenario, and some people might think, maybe one day. But I think this day will come soon, and the technology is here today. Why not use it? And what it can do for us is really to transfer data automatically, to provide overview of the status of equipment, samples, materials, people, activities. It's the basis for the analytics, for decision-making, for data sharing, collaboration, and it really helps us to focus more on science and less on the actual recording. So, and now finally, I have a slide with clouds. So, for the perfect storm, what do we need? Well, we have the Internet of Laboratory Things, but there are more elements to it. It's the data storage, it's a technology convergence, it's the industry standards, and the analytics of all the data that we are creating to form this next generation of lab experience. So let's have a look at these elements. Technology convergence, what does that mean? Well, today the scenario is very often like there's one or more LIMS, definitely different electronic lab notebooks, maybe a laboratory execution system, a couple of inventories for chemicals, materials, equipment, scientific data management system, and there might be more. And this makes it very complex. Now with technology convergence on a system, on a platform that is open and connected, it will become much easier when it's possible to capture data with a mobile device, access data with a mobile device, even do the review on a mobile device very quickly in the lab, very comfortably, having all the information accessible. That is part of the platform where it's stored and managed. So this can be one element that makes it much easier, one of the circumstances that help this perfect storm and this perfect lab experience. But there's more to it. So we just talked about the data. And when we have a lot of data, one of the buzzwords are big data. So with big data, we are talking about veracity, volume, and variety. Veracity, with the integration of all these things, I think that's already taken care for. It's the truthfulness of the data. But we still have a huge volume, and the more things we have in the lab, the higher the volume, and a huge variety of data. And so here are a couple of examples that are typical for the lab. And the data is structured, so with a high level of organization, like, for example, the spreadsheets, but also it can be text-heavy data with no predefined data model. So this is something that we need to handle. And why not standardize? And now I'm coming back to something that Gerhard did show before. Pistoia Alliance is one of the pre-competitive collaborations that looks into standardization. Or Allotrope Foundation with a laboratory framework, or Bioforum. So that actually also shows that there is a need that is recognized in our industry that we need to standardize, and which is one element for this perfect storm. So the way how it looks like is that we are collecting data from different data sources and instruments. We are converting them into a standard data format. Now they need to be stored, and something that we are finding more and more that organizations are using the data lake technology, and then even store the data in the cloud, and then use the data, reuse them for other experiments or just to get insights into different areas in the lab. So the last aspect is the big data analytics, because big data itself is totally useless. We need to do something with the data, and the something can be the analytics. And therefore, we need the contextualization. So is it scientific data, collaborative data? Is it maybe coming from production? Then we already talked about the standardization of the data. And we need to think of, okay, what's the goal? Because in order to choose the right analytics for my data, I also need to think of, okay, what do I really want to achieve? Do I only want to describe what has happened? Or do I want to maybe diagnose what was the reason because that happened? Or is it predictive, like with trends, what might happen? Or prescriptive, what we saw before in the little cartoon, so this is how you could solve it. So I think the questions in this context are very important, and then to define which tools I'm using for it. And the data should be available on a real-time basis, globally, to make really use of it for decisions. And in our environment, it's so important that it's also compliant. So it needs to be compliant with regulations, and they are becoming more and more. And finally, a system needs to understand the science. It needs to understand the different kind of data that we are creating in research, in development, in the lab, in quality. So when all these elements are coming together, and in the right way, then we can really create this next generation of lab experience. And I would like to share with you now some examples how this could look like. So let me see if that works. Nope. I need to. Okay. So in this example, it's about the overview and the insight in the lab. So to identify the analyst, so he's coming into the lab, he's automatically identified, he looks at the incubator and gets information about the sample. Also about the temperature in the incubator. So this is a way how we can envision that it works today. So knowing what's in the lab, knowing the status of equipment and everything without any physical interaction with a laptop, computer, and everything, get the status, maybe even read a procedure on some Google Glasses. The next short example is the laboratory execution. So to identify the user, with auto registration of materials and equipments, then to interact hands-free with the software, merge data from the devices and the stored data, and to see the data on a virtual screen. So just with the motion control, getting new data on the screen, and then maybe even share this with somebody else who has the same information at the same time, maybe at another location, and being able to communicate about what is this person doing in the lab, maybe get some advice, have collaboration around this topic. So this is something that we envision. This could be about the better, easier laboratory execution experience. And a last example is about the social lab experience. So again, hands-free, focus on science, share the data and maybe the video, and get additional information.
Okay, Glass. Record observation on sample 155. Note, sample is homogeneous after 3 minutes of stirring. Sample is homogeneous after 3 minutes of stirring.
So again, just a short video snippet how we can imagine that people can work together. So just recording automatically what has been done in the lab and share it with someone else who immediately gets the insight, can make maybe a decision based on this information. So it's just a couple of ideas, but I think they really serve as an inspiration what can be done. And there's probably much more possibilities, and but I think that it's really the direction we can go and that we will go. So the value that is really coming out of it is the compliance aspect, it's the efficiency, it's the easier and faster decision making, but also the collaboration aspect, as we have seen at the last video, knowledge management, and at the end it's really cool. And not only for the sake of being cool, but to advance the lab, to get to a internet of laboratory experience, maybe. So then I thank you for your attention, and I'm ready for any questions.
Thank you.